Howdy, 8th graders. Today, we are going to get started on EE Standard 8. Yes, we are still in this giant EE expressions and equations strand, but this is the final standard of it, Standard 8. Then we get to do something else that still, of course, involves equations and expressions the whole time. So you guys need to get out page 49, the one with the bicycle on it. Get your pens, your pencils ready, everything and anything you use to write some excellent notes, and here we go. All right, this is called Who Will Win the Race? It's a bicycle race. That's why there's a bike on it. Here's what it says on the top. Kevin, that got cut off there, but that name is Kevin. Kevin and Nina are competing in a bike race. Here's some information that we need to know to help us. When Kevin is 90 miles into the race, he is in first place. Nina is in second place and is 15 miles behind Kevin. From this point, Kevin continues the race at a constant rate of 25 miles per hour, and Nina continues the race at a constant rate of 30 miles per hour. Here is the big question that I want you to address. When will Nina catch up to Kevin? When will Nina catch up to Kevin? Can you tell that she's eventually going to catch up to Kevin from this data? That's the first thing we need to make sure we're all aware of. This constant rate for Kevin compared to this constant rate for Nina tells me that eventually Nina will catch up to Kevin. So make sure your brain is processing, yes, that will happen. And our question here is, when? So let's take a look at what we have on the rest of this paper. It says, solve this problem using at least 2 of the methods listed below. Don't forget to write a final conclusion in the space below. We'll get to that conclusion eventually at the conclusion of this video. First, let's look at the options we have here. Your first option is you can draw some kind of picture to help you solve this. That picture could include, I don't know, number lines, bar graphs, I don't know, whatever you think would make sense to you and help you. So that's one option. You could draw a picture. You could create a table of values. See if that could help you, a table of values. You could try to make a graph, and I even pre-labeled some things. I put the numbers on there, but if you make a graph, give me some more words so that I know what your graph means. Or there's this other methods box. Gives you some ideas here. Maybe you want to use some equations. Maybe you want to do some guess and check. Okay, it tells you at least 2. We're by the end of this, we're going to have all of them or almost all of them filled out. What I want you to do right now is I want you to pick just one of these methods. Pick one that you think I can try this way and give it a try and solve it with just that one method. And then after you do that, so you're going to pause me in just a second and try your one method. After you must have one of these boxes filled out in whatever way makes sense to you. It's okay if it's not correct. Try one of these boxes, pick one, try it. Make sure you have one filled out before you come back and push play. So everybody pause me right now. Okay, let me share with you what I often see happening first in classes. I walk around and students are working on this. A lot of students go for this table box first. Did any of you go for the table? And if you didn't fill in the table one yet, what should you probably do right now? You should probably fill in the table one with me, right? Now, this is often how people start the table. They see these 2 pieces of information, Kevin and Nina, and they put them in a table like this. But I want to mention here that in this table, there's a couple of important things happening. This shows me that you are keeping in mind when will she catch up, because you stopped when things became the same. But there's also something missing here. This question here was when. When is that going to happen? So I need to add something to this table to help me understand that it's a when question. And you might have something already added to this table that I didn't have. If these are all distances calculated, so first I want to make sure we understand, I started Kevin at 90 because we're jumping into the story when they're already he's already 90 miles into the race. I don't know what happened before that. So I'm going to jump in with my information when this story jumps in. He's in first place. And Nina's in second place, 15 miles behind him. So I took 15 miles, 90 minus 15 is 75. So these values in the table are both miles. And then after 25 miles per hour, so what I did is, how am I moving these? Well, I moved them based on the time that has passed. I added 25 miles to Kevin's distance every hour, and I added 30 miles to Nina's distance every hour. So I need a column that demonstrates what's happening compared to their distance. We actually have two separate relationships going on. We have one for Kevin, his time and his distance, and we have a separate one for Nina. So we could actually even write these as two separate tables. We could have one table for Kevin that's hours and distance for Kevin, and we could have one table for Nina that's also hours and distance. They're actually two separate relationships, one for Kevin and one for Nina. You can sometimes put the two relationships together as one table as long as you recognize that this is the hours and this is the distance. So these two go together for Kevin. And then we're going to skip this middle column and look at these two going together for Nina. But really, again, we have two relationships happening here. One for Kevin, his hours and his distance, and one for Nina, her hours and her distance. So really, this is miles, and this is also miles for two separate relationships. So be careful with your mathematical labels and make sure you understand what you're looking at. Now, how many hours have passed at this point in the story? Well, frankly, we don't know. We don't know how long they've been in the race at that point. So we're going to call this hour 0 for us, because as far as we're concerned, this is when we jumped into the story. This is when we came into this. And after 1 hour, that's how far they've gone. After 2 hours, after 3 hours, this is the point where they've hit the same distance. Now, maybe you already did a different representation, but my other question is this. If you got a table now, an accurate table showing Kevin and Nina and their distance over time, can you perhaps try the graph portion of this? Once again, please pause me and see if you can make graphs. Now, here's the thing, you guys. I kept saying there's two different relationships, so think about how many graphs should we have on this thing? Pause me and give this a try. Okay, check out my graph here. Does yours look anything like this? I color-coded it and labeled things because they're pretty close together, and I wanted to make sure we could distinguish. This green line right here represents Kevin. So I got my information from the table, but then I also recognized that there's a slope happening here. You guys remember all that stuff about slope, the rise over run? This graph over here, so I labeled these things, make sure you got it all labeled. Hours down here, miles over here. So I saw that Kevin, the green line, he's gonna start at 90. That's his y-intercept. And then from there, he went up 25 every hour. So I went 5, 10, 15, 20, 25 over 1. Up 25 over 1. Up 25 over 1. Up 25 over 1. There really is a slope and a y-intercept in this scenario. Okay, and then Nina started at 75, but she went up 30 over 1. 30 miles per hour. 30 miles per hour. 30 miles per hour. Does this graph answer my question? Where do you think the answer to my question is? Well, here in the table, it was where the information was the same. Here in the graph, it's also where the information is the same, which visually means where do the lines, and this is an important word, where do they intersect? Okay. We can call that the intersection. It's where the lines cross. And these two lines happen to cross. Look, it's an ordered pair. 3, 165. It verifies exactly what we saw in the table. 3, 165. But once again, there are two separate graphs here because we actually have two different relationships. And that means we can do what we did in the last standards, a couple standards ago. I don't remember where we are. But here, this scenario right here can really help us. This should look familiar to you, and maybe some of you already did this. Maybe some of you are like, Ms. Gown, this is what I did first because this is what felt right, is the algebra. It's always what feels right to me. Kevin started at 90 and is going 25 miles per hour. Well, Nina started at 75 and is going 30 miles per hour. If they ask me when these two are going to be the same, when she'll catch up, we've done problems like this, remember? This turns into an equation with variables on both sides. If I'm asking you when she's going to catch up, I'm asking you when will Kevin be the same as Nina? When will they equal to each other? And we can totally solve this. Minus 25x minus 25x. 90 equals 75 plus 5x minus 75 minus 75, and 15 equals 5x. Divide by 5, divide by 5. X equals 3. What does that 3 mean? Well, it means the same thing as it means in all these other questions. The question was, when, here's the big question, when will Nina catch up to Kevin? Well, we verified it 3 different ways. When will she catch up to Kevin? After 3 hours. And we also know after 3 hours, that distance will be 165 miles. Now that does leave us with one more right here, the picture. I want you guys to come up with whatever picture you think could show this. I'll be honest, this one's always the most challenging to me because I prefer these much more mathematical methods. But I look forward to seeing your pictures. Maybe you draw 2 people on bikes on a number line. I don't know. Draw a picture for me, and that's actually what you're going to submit for me today. Is I just want to see, I want you to submit for me, hold it up to your camera, and just show me, here's my picture. However goofy you want that picture to be. Draw a picture for me and submit it. Thanks.